Hello, everyone. This is part two of the video. As you saw, I wanted to upload a video yesterday, Friday, but I wasn't able to because things just keep piling up in terms of work. But it's just before supper times, just before it's getting dark, and so I decided that it's a good time to make the follow-up video on what I was discussing with Quadratics. I will link the video below in the description so that you can see exactly what I was referring to. The title of the video was the honors student who failed that short little math quiz on discriminants. And we're really going to have to talk about, I've been talking to him about his priorities and whether or not he's in the right level. But anyway, those of you who don't know me, if you're new to the channel, my name is Alfred Cromwell. I am the founder and president of City Tutoring. It is a tutoring agency, also an educational agency that is dedicated to excellence. We work nationwide, but we have our office, if you want to ever know where it is, it's here in Lynchburg, Virginia. And we serve local, of course, but we also do a lot of national and also international. Last year, for example, we had students from all over the world. We had students from the United Kingdom. We had one student from France. We had two students from Spain, five students from Germany, and then a couple of students were from South Korea. And they were interested in coming over to the United States, all of those students, to get their university, their college degrees in different colleges here in the United States. So the experience was very helpful to them. Before I begin, though, I wanted to mention something. On Monday, I'm going to show you something that I had neglected to tell you. I didn't want to say it until today, but have a look at this beautiful gem that I have, and you have no idea. You'll never guess what I have in here, what I found in this book. It's called Differential and Integral Calculus by Granville. And just to give you a preview, I mean, look at all these mathematical notes from the early 20th century in here. But that's not this is in and of itself, it's a gem. It's a wonderful thing. But the book itself is just really, really good. And I found something in the book it just happened, and it was just an amazing experience for me. Just so fascinating to own this piece of history. Now, the book itself it's not so much that the book is historical, although it is, but just to have someone's notes in here is really an amazing thing. The book was published, let me just double check here to make sure that I'm giving the correct date. It was published in 1904. 1904. So it's more than 100 years old. And it was published by William Anthony Granville and Percy Smith by the up in Boston. All right, so on Monday, I'm going to give you a review of this book. It is a calculus textbook, and again, as usual, very little graphics, if any. These are the only graphics you see, of course, the ones that are relevant to the text. But you'll see that it's just an amazing resource. Not so much, I would not say it's the most rigorous calculus textbook out there, because back then they were still kind of developing some of the modern day rigor that we use. But I do like a lot of the problems. They have differentiation of implicit functions, and they also have partial differentiation, and they have successive differentials. So there's a lot to pack in here. Maxima and minima. And they also have, let me just all the different rules for differentiation. So anyway, I'll share some of the problems in this book that I think are really, really good on Monday. And what I wanted to do in this video was, we didn't finish up. The last thing we did in the previous video was I showed you how students often, with their algebra, they lose a root. Well, now we're going to see another strategy and another common mistake that students make when they're solving quadratics. And I'm also going to tell you a little bit about what to expect, how to find a vertex very quickly, and also what to expect from graphs when you're graphing them. So it's going to be a short video because I'm running out of time today, but I hope it's useful to you all. And I'll be uploading again, like I said, for the remainder of this year, it's mostly going to be book reviews. Sometimes I'll add in a lesson or two, but it's mostly going to be either book reviews or topics related to mathematics. from a more descriptive perspective. And then starting in January, we start all our courses starting in January. If you're interested in our courses, you can email us. It's City Tutoring Maths with an S, City Tutoring Maths at gmail.com. And either myself or one of my assistants will read the email. And by the way, in January, we will be making available to you a mailing address. If you want to send us any support that you want to send us, any interest that you want to send us, I do like to receive letters. I love to receive your correspondence, your letters, your gifts, anything you want to send to further the cause of rational thinking, of mathematical thinking, of rigorous mathematics in an age where it has been all kinds of rigor has been dispensed with, and we are seeing those of you who have children, you're seeing it in the schools, in the high schools. There's it's just a joke in many of the schools now. I had a class this morning, Saturday morning, a big class actually. They were preparing for the SAT, and I asked them about the discriminant. And yes, the good news is a lot of the students knew what the discriminant was. Their teacher had explained what the discriminant was, but they couldn't apply it. So they had a vague notion, but they didn't know about the set of real numbers, the domain. They said that most of their teachers just told them to plug it in. Can you imagine that? Just plug it in, they said. So anyway, I have some choice words for that, but I'm not going to repeat what they are because, there's no time for that. So anyway, here goes. All right, so as you can see on the board here, just as a recap, we're still talking about quadratic equations. And the restrictions are, well, the formal way of writing is ax squared plus bx plus c is equal to 0. And a cannot equal 0. Otherwise, you have a linear equation. Also, a, b, and c must be in the set of real numbers, as we said in our previous video. So there are really three ways to solve quadratics. One is to factor. The other is completing the square. And the third one is the quadratic formula. Now, the quadratic formula works for all the quadratic equations, but sometimes you're going to find it more useful to complete the square or to factor rather than using the quadratic formula. And I put in some notes here for you. When you're factoring, how do you know to factor? Well, whenever the product of two factors is 0, that means that at least one of the factors must be equal to 0. So I put a little example here. 3x minus 2 and x plus 4 equals 0. And we have x equals 2/3 and x equals -4. Now, a quadratic formula must be written in the standard form before you use factoring. I wanted to make that very clear. The other thing is, because, for example, let's say you got an equation like this. This is what I was going over this morning with my students, with my Saturday group of students. What if you got a test and they gave you the equation in this format? You're going to have to write it. It's better to write it in a standard form, right? So the way you do that is we use the distribution principles and the multiplications, and then we have, and I heard a student, by the way, it was hilarious. The student said, foil. I said, don't use that cuss word in my class. We don't foil here. We use math. We don't use that terminology. So if you multiply, you get 3x squared plus 10x plus 3. All right, if you move everything to the other side. All right, now you can factor this. If you factor 3x squared plus 10x plus 3, you get 3x plus 1 multiplied by x plus 3. And you set those terms equal to 0. And now we have the answers here. We would have x equals, well, 3x plus 1 would be negative, if equals 0, would be 0 minus 1, that's -1. So 3x is equal to -1. And therefore we divide on both sides by 3. So we have -1/3. And of course, x plus 3 equals 0. That's going to give you x equals -3. All right. Now, when can you factor? So if a, b, and c are integers, and b squared minus 4 times a times c, remember we said that that is the discriminant. If it is a perfect square, if the value of the discriminant is a perfect square, you can factor. You cannot factor if it's not, right? So I put in a little scheme here. Perhaps it will be helpful to you if it helps you remember. If you have x squared plus even number times x, so if your b basically is an even number plus a constant, then you will not be able to factor. Why? Because then that means that the value of your discriminant will not be equal to a perfect square. A lot of students didn't know this. A lot of students. And this is something you should have down pat for your tests. The other thing to know, let's see, I want you to look at this problem on the board. X plus 2 divided by x minus 2 plus x minus 2 divided by x plus 2 is equal to 8 minus 4x divided by x squared minus 4. I want you to pause this video. Pause it and let me know what you got for this, and then we'll see if you're correct. Just pause me. All right, did you pause the video? Don't jump ahead. I want you all to do it. The answer that you should, or the answers rather, let's break it down. First, you have, typically when you have fractions like this, I like to just go ahead and cross multiply to get rid of that denominator. So x plus 2, that means you can rewrite that as x plus 2 squared. Same thing with your x minus 2's here. So far we have x plus 2 squared plus x minus 2 squared. And since we multiplied the other side by the same denominators, we got rid of that denominator and we have is equal to 8 minus 4x. All right, now, if we clean up and combine like terms, x plus 2 squared, this means the same thing as you should know from the formula, x squared plus 4x plus 4. And then you have x squared minus 4x plus 4 is equal to 8 minus 4x. And let's combine your like terms. Continue your cleanup work. We want to clean up. X squared plus x squared is 2x squared. And then we get 4x minus 4x. That vanishes. So we're left with 4 plus 4, which is 8. So now we have 2x squared plus 8 is equal to 8 minus 4x. Isn't algebra beautiful and lovely? All the things you can do. This is just amazing. And now you want to set that equal to 0. So you have 2x squared. You move the 4x to the other side and subtract the 8. And now you have 2x squared plus 4x is equal to 0. And therefore, you can factor now. You can take out, extract that factor of 2x, the term. 2x is equal to 0. X is x plus 2 as well, is equal to 0. And therefore, your answers are, now tell me if this is correct. You have x equals 0 and x equals negative 2. Is this correct? I want you to really carefully evaluate it. All right, if you said that this is correct, if you said that both of these answers are correct, you're wrong. You're wrong. Why is that? You've gained a root in this case. But remember what I always tell you. When you solve any equation, the equation must hold true for the value that you're saying that it's worth. So if we plug in for x equals 0, we get 0 plus 2. Let me put it on the right here. We're saying that x is equal to 0 as one of the solutions. So that means 0 plus 2 divided by 0 minus 2. Right? In the original equation, plus 0 minus 2 divided by 0 plus 2 must equal what is on the right side. It must equal 8 minus 4 times 0 divided by 0 squared minus 4, which is just minus 4, by the way, but I'll put it in anyway, just so that you see, those of you who need to be breaking it down. So you have 0 plus 2, that's 2 over negative 2. That gives you negative 1 on the first fraction here. Then you have 0 minus 2 divided by 0 plus 2. That's negative 2 over 2. That's going to give you minus 1. So that's plus negative 1, which equals negative 2. Then on the other side, you have 8 minus 0 divided by 0 minus 4. That's going to give you 8 divided by negative 4, which is also negative 2. And last time I checked, negative 2 is equal to negative 2. And therefore, 0 is most certainly a correct answer. But now notice very quickly what happens when you plug in negative 2. And by inspection, we know that it is not acceptable because you get infinity, or undefined, as some people might call it. You cannot have 0 in your denominator. So if a student were to put 0 and negative 2, I would mark that wrong. 0 cannot be a solution to this equation. And therefore, because look what happens. 0 squared, sorry, negative 2 squared rather. Negative 2 squared minus 4. That's going to give you positive 4 minus 4, which equals 0, and therefore you cannot do that. So be very careful. So I hope that you've seen that the zeros, that when you find the zeros of various polynomials, when you reverse the process, you can find a polynomial that has a specified set of zeros. And if n zeros are specified, a polynomial will have a degree that will be required. Degree of n will be required. Okay, we can prove it probably in another video, but because I don't have time, but there's a proof of that we can do. The other thing to take into account is this that I shared. All right, there's another way of writing quadratics. This is the vertex form. And to find your x and y intercepts, your y-intercept is always c, by the way, in a in ax squared plus bx plus c. All right, so you can consider c to be your y-intercept. Now, if you solve ax squared plus bx plus c to find x-intercept, now again, if the discriminant is a perfect square, you can find the x-intercepts by factoring. If not, you need to use the quadratic formula. The other thing is that you can find the axis and the vertex either by, this is very important, negative b over 2a. And I know a lot of you have covered that in your schools, I hope, especially at the Algebra 2 level. Or you can rewrite the equation as this, a times x minus h squared plus k. Vertex is always hk, and the equation of the axis is x equals h. Now, a couple things that we talked about. If your discriminant is greater than 0, you have two x-intercepts. If your discriminant is equal to 0, the graph is tangent to the x-axis, meaning that there is one x-intercept. If your discriminant is less than, is less than 0 rather, I should have written there are no x-intercepts. Put it in here. All right, so hopefully this is very useful to you in your when you're studying quadratics. Now, a couple things also that you should know about the graphs themselves. So I'll end with that. If a is greater than 0, and when you have this vertex form, your graph opens upwards. If it's less than 0, then obviously graph opens downward. All right. That was the other thing that was missing there. All right, so I hope that this was useful. Let me know in the comments down below. If it was useful, then continue to please support us by subscribing to the channel. I am very blessed. Just look at all the work. I don't know about you all, But I am just amazed that just a month ago, just a little bit over a month ago, around October, this channel only had 126 subscribers. We are now approaching 6,000 subscribers. Just think about that. Let that sink in for a moment. How much growth? Perhaps might be a good experiment to test it with exponential growth, perhaps. But just look at how much we've grown, and all thanks to the wonderful young people who want to have a channel where math is serious, where mathematical truths are respected. You're not going to get anything watered down here. You're not going to get this whole, we're living in an age of a lot of political correctness. This is we're not going to waste our time with that here. We're actually going to get the real, the pure mathematics, and that is why people come to us. People come to us because they know exactly that we say what we mean here at City Tutoring. They know that we're going to share those truths. They like to know. People like to know how what you want to do, why you want to do something, and how you're going to do it. And that's what we're setting out to do. How, and then I had a recently I was in a shopping center, and someone was talking to me, and they said, how far do you plan on taking your students? Because it seems to me, there was someone who said, in your videos you seem to push them too much, you push them too hard. How far do you want to take them? Do you want to break them? Was the And you always get negative questions like that. It's so silly, isn't it? I said, I don't want to wish to break anything or anyone except bad habits. And there's a lot of bad habits out there. So if you come to this channel and you're expecting, the watered down, the usual thing, the super fake edited, you get there's already, I'm not going to mention them, but there's already a lot of channels for that. This is actually a channel where I am giving you the time that I have, the little time that I have, because I have so much work always, just for you, because I believe in mathematical rigor and I believe we can all benefit from it. And it is my way of doing community service for you. And also, of course, it is also a way to get you acquainted with City Tutoring and what we do, the work that we do. We work with a lot of our students, contrary to popular perception. A lot of our students are actually come from underprivileged backgrounds. A lot of them have had a hard time at school, and they haven't had the education that they deserve. The education that not only do they deserve, but that they need, right? Why do I say that they need that? Because the future is mathematics. That is the future. It has been the future for a very long time. And no matter how you want to hide the information or not recognize this is a fact. And there was a study done the other day, and they were saying that students who spend a lot of time on tablets and and within the public school system are doing atrociously bad at math. In fact, American math test scores keep on going down and down and down. We are in a downward spiral in America with the test. Not only with test scores, that's not the whole story. It's not just test scores, right? Because anyone can prepare for a test. It's also the standards. It's the standards, it's the convictions, it's the desire to do better than what we do. And so that's what we're here for. We're here to fill in those gaps. Thank you, everyone. Have a great night. May you have a blessed weekend. Hopefully, tomorrow you're in the company of your loved ones and the company of your family and with the Lord, and rejoicing at just so much the progress that we're going to be making. Thank you all.